Or so we were supposed to consider the graph of function logarithm, which is a graph of a function that passes through point 1 on the x-axis, logarithm of base 3 function x. And then we were supposed to subtract number 1 from it, which means the graph was supposed to go down by 1 unit and have pretty much same shape, but moved down, so it's still the same asymptote, and logarithm base 3 of x with 1 subtracted from the whole thing as what we were supposed to find, and looks like an exercise number 69, something like that appears. So graphs of logarithms were introduced. The key part was to realize that the main for those functions was positive. Only values of x to the right from y-axis are allowed to take into the logarithmic function. So let me refresh a few more ideas here about those logarithms, such as, for example, an exercise that deals with the converting back and forth, like problem 27, logarithm base 5 of 25 is equal to number 2, because this logarithm is actually a power, so 2 is a power that I have to raise my base 5 to get 25. So the key idea that we have to get used to working with logarithms is the fact that when you have the exponential equation, 5 squared is 25, which is pretty straightforward, we can rewrite it in a little bit unusual way, in a way that your power tool is called with the word logarithm. So logarithm is nothing else but the power that I have to take my base number 5, and they put it here in the base of this logarithm, to produce as a result number 25, so they apply this to 25. So if I have problem number 26 here to consider, then wondering what is logarithm base 8 of number 8 supposed to be equal to, I'll rewrite this base 8, which we have here in the base of logarithm, raise it to some power to produce 8 as a result. And the power has to be 1, so this whole logarithm has to be equal to 1. And that's what actually brings us with the interesting statement called property of a logarithm that says if you have logarithm with a base a applied to number a, the result is 1, simply because the first power of a is the same a, right? First power does not change anything, and the power is my logarithm. So 1 is what I have for the power of base a. That's, I guess, good to realize. And using this idea, we will actually work out a number of exercises in this textbook. So I'll keep this a so-called property of logarithms. Let me take a look at exercise 25 that will bring us to another very popular property of logarithms that wants us to take a logarithm of base 2 and apply it to number 1 and see what power I have to take my base 2 to produce number 1. I want to say 2 to the power of 0 is 1. So this logarithm is equal to 0. And that's actually what will bring me to another property of the logarithms. This property will say that logarithm of base a applied to number 1 is going to be equal to what? Well, some power I raise a to get 1, and that power has to be 0. So the logarithm is power, so it is 0. So these two properties is what we will encounter every once in a while. So they have them here for us outlined separate. It turns out that there is one more very popular property of logarithms that I want to point out here. That says if you're applying your logarithm of any base, say a, to a to the power of r, all you get is r. This property could also be well verified using the favorite definition of logarithm. So if your base a here is going to be raised to the power, and the power is 1 because that's our logarithm, right? Number 1. Then, oh, sorry, that's r. Wasn't careful. Clean this real quick. See, I guess need to wake up, I guess. So it's r. So if I raise a to the power of r, well, I'm gonna get exact same a to the power of r. So the base of logarithm and base of power will cancel each other out. So this could be illustrated by looking at the problem number 17, for example, that I can write as a logarithm base 2. Instead of 8, I can put 2 to the power of 3, right? Because 8 is 2 times 2 times 2 to the third power. And this is actually equal to number 3. So it is indeed 3. It looks like these properties are helpful for us not to every time go over the same ideas to visualize what the actual definition of logarithm looks like, but to actually see that if you have something like, for example, here, logarithm base 10 of a square root of 10, which is 10 to the power of 1 over 2, then the result is just 1 over 2, because again, according to property above, we have same bases that they will cancel each other out. Following this idea, it turns out we can write down another property of logarithms. I can raise base a to the power of logarithm base a of some letter, I like to call it as m, and the result will be that same letter m. So this is analogous property to what I just had above. An exponent and the logarithm have same bases. So those bases disappear. And I can try to see this by doing the exercise, like, let's see, the problem was the exponent. Maybe it's in the next group of exercises. Do you have anything related to it? See it. Well, I guess we will do more problems in next section, and we will, of course, encounter this property at work. And let me see what else is in this section. And looks like on the next page, like problem number 87, for example, they solve some equations with logarithms. So let me try problem number 87 with logarithm base 3 of x equals number 2. So all of these exercises, they call in for one thing: get rid of the logarithm, use definition, write 3 base, logarithm is a power, so base of 3 raised to the power of 2, and produce x, whatever's under the symbol of logarithm. So x equals to 9, and we've got the result. So the idea is to have logarithm disappeared, and that's the point. How about number 91? Another use of definition of these logarithms. This is going to be a logarithm base x of 4. And they say it is equal to number 2. So right away, I'm going to rewrite this with a base x, power is 2, and the result is 4. So we have a little equation to solve. And one can say, Alex, if x is 2, so 2 squared is 4, then I have my result. And indeed, it looks like we solved this little exercise by just taking the logarithm and making it go away. That's all we need in here. So I'd like to move on to the next section that actually utilizes more properties of these logarithms, the properties that I actually discussed now, and you can see them here outlined in the boxes highlighted. So I have the property that I just listed and was trying to look for the exercise, and it appears, turns out, in the next section. That's why I'd like to take a little look at the next section and, well, just try some more of little exercises here, like problem, for example, number 13, that works with another logarithm. They say take a logarithm base 3 of 3 to the power of 71 and see what this is equal to. And this is equal to number 71 because of the property here on the left upper side, where we apply logarithm of base 3 to the 3 to that same power. So they cancel each other out, and we just have the power left. So pretty straightforward application of that power expression. How about 17? That's the one that I wanted to find in the previous section and couldn't, but now it's here. So I have a tool which is raised to the power of logarithm base 2 of 7. So base of logarithm and exponent are the same, so they just go away and we get 7 left here first. And this is it. And I guess that's nice to realize, right? So we're working with logarithms, and let me try another exercise here, number 15, with that pencil next to it. So they recommend us to work it out. And I write this as a logarithm base e of e to the power of -4. Please notice that the base of logarithm and the base of that exponent are the same. So they cancel each other out, and we just have a -4 right away. So it's not that bad, right? These exercises actually are pretty straightforward. I say, what about if we have problem like 22? What if we subtract a pair of logarithms? Well, it turns out there'll be another property at the play. So if you subtract logarithm base 8 of 16 with a logarithm base 8 of number 2, then what you're going to need to do is divide the arguments of these logarithms. 16 divide by 2, and this will produce you 8. And then I should be able to simplify this further, utilizing the property up here above, which is going to give us 1, because the base of logarithm is 8. We take the logarithm of 8. So since base is the same with the argument of your logarithm, then they cancel each other out, and we just get number 1. So that's an interesting thing to notice. If you subtract the two logarithms, then you have to divide. And turns out the similar things happen in number 19 when you add the logarithm base 8 of 2 with a logarithm base 8 of 4. When you add these logarithms, then what you have to do is multiply. So when you subtract, you divide. When you add, then you multiply. And when you multiply 2 by 4, you get 8. I say, oh, that's again going to be equal to number 1, because that's a logarithm base 8 of number 8. Yes, that's correct. And that's another property of logarithms that actually appears here on the next example. It says, if you add the two logarithms together, then instead of their sum, you're gonna multiply m and n. And if you subtract, then you're gonna need to divide. Just like with powers, when you multiply two powers, same base, you add powers, and when you divide, then you subtract powers, because logarithms are powers, and that's why this is being done. So I can look at another exercise here. Let's say problem number 25, and see how that feels. Let me write it. 25. That has a power which is a difference of those two logarithms. So can I just say 3 is raised to the power of logarithm base 3 of 5/4? Because we subtract logarithm of 5 and logarithm of 4. So as a result, I get logarithm of 5/4. And please notice that we're going to use the property here once again, the one that I just produced up above, and get the answer 5/4, because again, base for the power was 3, and the base for the logarithm they're the same. So as a result, you get just that 3 or 5 quarters left, which is quite interesting, right? So we're working with various logarithms in here. And I guess that's the plan, to feel more and more comfortable with all of that story. So let me try another exercise. So how about problem number 28? This exercise 28, we have a e raised to the power of logarithm. And now look at this base. It's e squared, taken of number 9. Well, that's e squared. Why is that e squared? Well, whatever they want, we just want to simplify that. And to be able to simplify, I probably want to see what is going on with this logarithm base e squared of number 9. Let's try to recall the definition of logarithm. In other words, let me see what is e squared base, what power of that e squared. Let me write it a little bit nicer. E squared, right? Some power gives us 9. So it looks like that we have here some kind of square thing, right? In fact, I know that 9 is 3 squared, right? So if I take e squared and raise it to the power, I actually have those squares that may not be useful. So I can get rid of those squares and end up with something that looks like just e raised to some power. Again, I don't know what power of the e it is, but that power is 3. That's what I know. And then from here, I can go back and instead of my logarithm, write it as a logarithm base e of number 3, right? And that way, this bases e and e, since they're same, will go away, and I just end up with number 3. So that's kind of unusual. Yeah, well, I guess that's the exercise, which is a little bit offline. So I think it's interesting if you think about it sometime later or tomorrow, just to see how it went over the definition of logarithms. Anyways, other part of this section is talking about things like taking ln's of various numbers, like ln of 6. Well, if you want to find what ln of number 6 is, you need to use a calculator. So what I can do is just grab a favorite scientific calculator. So you can just go to the Google search and start typing scientific calculator and get it here. So Desmos is what I usually utilize. So in this calculator, I need to enter ln, and to be able to, I select so-called functions. So once I click on these functions, You see two choices. One of them is ln, and the other is its friend log. So I choose ln. So once I click on ln, it appears. And now I need to enter number 6. So to be able to go to 6, I need to select main menu where the numbers are, or you could just use a keyboard and get 6 from it. So this way you get a ln of 6 entered, and you can see that this is just some kind of number that is a lengthy decimal. Well, this is just a calculator exercise. So just put number in the calculator and that's about it. So we have tried to simplify using calculators. So this is the way to go with the exercises, and it looks like there are some problems that deal with various complicated looking structures. I don't want to worry about them because I think they get in a little bit too much into these logarithms. So I can try to take a look at exercise like number 60, and you will see that this is really all about getting used to the formulas that we just saw in the section. So if I do problem 60 with a logarithm base 2 of 1 over x added with a logarithm base 2 of 1 over x squared, then you're gonna put a logarithm base 2 together as a product. Remember, when we add those logarithms, then what I have to do is multiply 1 over x by 1 over x squared, and this is it. So whatever the result is, it's a fraction with 1 on the top and the third power of x, right, on the bottom. That's our answer. So if you add logarithms, well, then you just put them together like that, and that's it. So anyways, yeah, if you need to have a break, that's fine. I know that it may be a little bit too much, or if you have some issue, you can always log out, because I make a recording, right? So it's not a big deal. You can always check the lecture recording, and that's it. So here we are using those formulas and various examples and various little exercises. And I just wanted to add one more little formula here that is called the property of power rule of logarithm. So if we have logarithm of base a, and we have some kind of number m raised to the power of r, then this power of r could be multiplied by our logarithm. In other words, the power you can bring in front as a factor. So you drop down the power of logarithm. This could be nicely visualized when you're looking at exercise like 57 here, for example, when you are dealing with a 3 logarithm base 5 of letter u. So what you can write instead of it is u to the power of 5 without that 3 in front. So you could just put the power on the top, just like that. You say, why do you need that? Well, they want to convert to so-called single logarithm. So the actual exercise has a little bit more. There's also 4 logarithm base 5 of v. present as well. Well, analogously, I can bring that power of 4 to v, so get v to the 4th. In other words, when they told you to get 3 log base 5 of u and add it with 4 logarithm base 5 of letter v, then the first guy will be logarithm base 5 of u to the power of 3. And the second is going to be logarithm base 5 of v to the power of 4. Why do you need this? Well, because then you can utilize the fact that we can put this as a single logarithm of base 5. We can just multiply u cube by v to the 4th and get the answer. Let's see, well, these manipulations leading us nowhere. I agree, but they preparing you for next section. I just want to take a little look at the next section that actually shows where this is all being utilized. And this is all being utilized in solving equations. Like problem 5 is something we already know how to do. We already saw in the previous section how to lose our logarithm, right? Definition says take base 4, logarithm is power, so 2 is a power of 4, to produce x that we applied our logarithm to. Well, 4 squared is the answer, so x is equal to 16. That's our result. Let me see, how about if I try problem number 9? On one side, I got a logarithm, and on the other side, I also got a pretty much same base logarithm. They're both logarithm base 4. One is taken of x plus 2. And on the other side, logarithm of base 4 is taken of number 8. So turns out that logarithm of base 4 is not needed here. I just erase those logarithms because they're of the same basis and produce a nice looking equation that I can definitely work out, right? X is number 6, then that's my result. So the key part is to get rid of those logarithms. And that's the idea of all of the exercises that we have in these sections. So when I have logarithm on one side is equal to the logarithm on the other side, and that's about, and that's the result. Oh, so you're wondering about the final exam. That's a good question. It turns out that final is week after next. We have a short semester, and actually next week we're going to do a review, and week after next on Tuesday there will be a final. So final will be on the 25, right? Tuesday, the April 25. So by that time we will finish with chapter 5. We're actually working on chapter 5, so that'd be the day when you get the final exam, which is going to be pretty much the same thing as a midterm exam. I'm going to email you the test by, as usual, by email. And once you got the email, you just need to work it out and send it back to me. So what you need is just to check your email 2 weeks from today. So it'd be the same thing as a midterm. And the next week, I'm going to talk about all that in very, very detail. We will discuss the final. I will email you practice final that will consist just like a midterm of couple of exercises. It's not going to be something real big. It's the same thing. I'm sure you're going to like it. So I'm glad that you're already aware that semester is coming to an end. So I guess this week is a good idea to keep working with these logarithms. So today and Thursday, we will finish up with the material, and then we will talk about the review and talk about final in very detail. So anyways, let me do another problem here to just keep solving equations with logarithms. How about exercise number 11? That problem has another pair of logarithms. On one side, the logarithm is multiplied by 1/2. We have logarithm base 3 of x here. And on the other side of this equation, it's multiplied by number 2 times logarithm base 3 of 2. And I will be using the power rule formula that appears above to have clean logarithms on both sides of these equations. In other words, I'm going to put in powers this 1/2. So I'm going to have logarithm base 3 of x raised to the power of 1/2. And on the other side, this will be logarithm base 3 of 2 squared. So those logarithms is what I can throw away. And that's the point of solving the exercises with logarithms. Lose those logarithms. And then we get x to find, and looks like I just square on both sides, right? Because power of 1/2, if I square it, then 1/2 and 2 will be multiplied and give us just first power of x, or just x, and that's what I need. I need x. So 2 squared, 4 squared is going to be 16, and we're done. So the key part is to have logarithm on one side and a logarithm on the other side of equation. And this way you can make those logarithms to go away. How about number 13? Let me try another one like that. And this exercise, again, there are some numbers multiplied by the logarithms. So I have 3 times logarithm base 2 of x on one side of my equation, which is equal to, I can say, -1, because minus means -1, because I want to make this be just a logarithm without any numbers. So these factors in front, such as a 3, I'll bring to the power, as well as -1, I'll bring to the power. So this will be a logarithm base 2 of x to the 3rd power. And on the other side, it will be a logarithm base 2 of number 27 raised to the power of -1. So the key part, again, producing those logarithms on both sides of my equation. So then logarithms will go away. So I'm going to just have x cubed on one side. And I can write this as 1/27, right? Because negative first power means I bring down to denominator my number 27. So it's 1/that 27. And then I can see what the answer is, right? Because 3 times 3 times 3 is 27. So 1/3, if I multiply it with itself 3 times, will give us 1/27. And we're done. This is the result. So the key part was to have a logarithm on one side and the logarithm on the other side, and then throw them away. How about if you do this? I think problem number 10 should be a good question that you can take a look at for today's quiz. You have logarithm on one side and the logarithm on the other side. So you can just throw them away and tell me what x is going to be equal in this case. And well, then this is our quiz for today. So once you're done, you can log out and enjoy the rest of the day. And if there are any questions related to your grade that I still have on the Blackboard, the grades. But remember to check that Blackboard, you need to use not a cell phone. With a cell phone, for some reason, Blackboard is not working. There's nothing we can do. In fact, this Blackboard will be the one that you use with computer. So homework will be what we did in class. And in class, we did look at the section in chapter 5, right? So what is that we looked on chapter 5? Well, it's 5.6, right? So we looked at sections 5.4, 5.5, and 5.6 today. So that's all we care about from chapter 5. And that's what we did. And yes, of course, homework will be due on the day of the final, just like we had it for the day of the midterm, right? For the day of the midterm, we had some of the homework due. I extended the deadline. I still accept homework for the midterm if someone didn't turn it in. I still have 3, 4, 5, 6 people that didn't turn in their midterm homework. Well, I'm waiting. I hope to get it, so you will get a better overall grade. So send me your homework if you did not send it to me. I'm talking about those people that did not send me those. So homework from chapter 5 is 5.4, 5.5, and 5.6. We also had homework from chapter 4. I think it's 4.1, 2, and 3. I think 4.1, 2, 3, and 4. I need to double check. Right now, I don't want to close this page because people taking the quiz. So if you're not sure what we did in chapter 4, just wait. I will show it to everyone. Of course, I will discuss all that again and again and again next week. But yeah, whatever we stopped at when we took the midterm, that's where you continue for chapter 4 and 5. So that'd be homework for the next time for the final. So advice is so far, do problems from chapter 5. So 5, 6 is what we looked at. We will continue with it on Thursday. I know that we need to do more from it, and I will, of course. But concentrate on 5, 5, 5, 4. So do those so far up to Thursday. And on Thursday, I will, of course, write down all of the sections that we covered after the midterms. So no worries. I will, of course, let you know what it is. I believe it's 4.1 through 4.4, but I want to double check. So anyways, forward. So yes, the final will be in 2 weeks, and in 2 weeks, I make a due date for homework, even though on Thursday, the following day, we will also have a class meeting, and I will have class grades calculated by that time. I'm talking about Thursday week after the final. And if someone wants to improve it, I wouldn't mind. I also like when students want to get a better grade, I help them. But we will discuss all that after the. So far, keep working on chapter 5. I think that's plenty for Thursday, right? And again, we are having a quiz right now. The quiz is exercise number 10. So please tell me what you think X is. Put it in the chat. And then you can go and relax.